Predictive maintenance promises a future of zero unplanned downtime, predicting failures before they happen. But this promise is failing. A majority of predictive maintenance programs are undermined by one critical, often overlooked flaw. That flaw is bad data. It's not a small issue. It's a multi-trillion-dollar problem for the economy. In a plant or remote job site, it shows up as false alarms that cause needless work or process failures leading to catastrophic breakdowns. We will now prove that the industry's shift to inspection apps is a direct response to fix this data crisis. So, what is bad data for a predictive maintenance model? It is the source of faulty predictions and unreliable insights. It can start with old sensors giving noisy readings, but often it's inconsistent manual data from routine checks. When this flawed data feeds your algorithm, the result is certain: incorrect predictions. This means unnecessary repairs or unexpected equipment failure. This data gap makes proving your return on investment nearly impossible. Without clean historical data, you can't forecast savings. The quality of your data input dictates the quality of your predictive output. Garbage in, garbage out is an operational risk. The most advanced algorithm cannot solve a data collection problem. To fix predictive maintenance, you must fix the data at the source. This is where mobile inspection apps come into focus. They are built to solve the problem at the point of entry. But how do they achieve this? How does an app turn observations into high-quality fuel for a predictive engine? The first mechanism is rigid standardization. Apps replace paper with digital templates, ensuring every inspection follows the exact same format. This structured approach builds a complete audit trail. It guarantees required checks happen on schedule, creating a reliable, unbroken data stream. The second mechanism is automated data validation. Digital forms use rules to prevent errors, like requiring a photo if damage is checked. Standardization and validation work in tandem to remove ambiguity and manual errors. They turn human observation into structured, machine-readable data. So what does this higher quality data look like in practice? It involves capturing much more than just text in a box. A technician can capture time-stamped photos of corrosion, record a faulty bearing sound, or scan an asset's barcode for objective context. Because the data is captured digitally, it's available instantly. A manager can see a critical issue flagged and dispatch a crew immediately. This granular, real-time data directly improves asset uptime. It provides the hard evidence needed to justify a repair or replacement decision. The difference is clear. From delayed, error-prone paperwork to an immediate, rich, and structured data feed for your predictive maintenance program. We asked how apps are more than digital checklists. The answer is next-generation capabilities, built-in intelligence and connectivity. Modern apps now embed AI to analyze inspection patterns. The system can learn that minor vibrations on a pump often precede bearing failure. This turns qualitative human observations into quantitative, predictive insights. The app starts the analysis right at the source. On top of that, these apps are integrating with IoT sensors. Imagine a sensor flags an abnormal temperature on a machine. The app can automatically trigger a human inspection to add visual context. This creates human-validated sensor data, the highest quality imaginable. Let's connect this back to the core PDM failures we began with. False positives, false negatives, and the inability to prove ROI. The consistent data from inspection apps builds the clean historical record needed for a credible ROI calculation. The missing baseline is solved. Rich media and AI pattern analysis give the context needed to reduce false alarms. The algorithm is no longer guessing based on a single data point. Here is the key insight. The inspection app is not a replacement for predictive maintenance. It is the missing piece that enables it to work. We started with the fact that most predictive maintenance projects struggle. They have analytics but have neglected their data foundation. The focus on inspection apps is the market's correction to this. It's a shift to actively powering the algorithm with trustworthy data. By perfecting data capture, companies are finally fixing the foundational flaw that has held back predictive maintenance. They are building on rock, not sand. So ask yourself, is your predictive maintenance program struggling with bad data? Perhaps it's time to stop tweaking the algorithm and start inspecting your inspections.